Hello everyone, I am Yaser Ali and I work as an AI ML testing engineer here at Testiva. Today I am going to show you how to evaluate the multi-LLM system, especially in the healthcare and medical domain. So start with the system overview first. This is the multi-agent medical assistant. On the left side you can see first is the medical conversation agent to answer the general queries. Next is the medical RAG agent to answer from its own knowledge base, and then followed by the web search agent to answer from the internet the latest news. And it has computer vision agents as well to answer the images query. So in short, when the user enter the query in the placeholder or even upload the image, the system will decide that which agent to pick from the available agents and then response. But here is the issue: we have to evaluate it properly that the system is actually getting the right agent from the available agents and then response. So to evaluate it properly, here we are using the DeepEval framework to evaluate these multi-LLM agents. So next, moving to the evaluation part. So this is the repo structure of this system. Inside the test script, we have multiple metrics to evaluate these. First is the conversation completeness to check the persistent memory. Then we have safety metrics to check the biasness and toxicity in the response. And then we have answer relevancy to check that the answer is relevant to the user query. And the last is test tool correctness to check that the agent the system is picking the right tool. So I'm going to show you the test relevancy configuration. The rest of the matrix configuration are the same. First, we are important the libraries like answer relevancy metric and DeepEval. Then we are using the system endpoints so it can handle our requests. Then followed by the test cases. These are the tricky cases we want to evaluate with these cases. First is the WAG question outside of the domain, multi-part question, and so on. So we wrap these cases into LLM test cases and then calculate the answer relevant metric with the help of LLM as a judge model. So we set here the threshold 0.7. Below this threshold, this case will fail. So I'm going to run this file. So after running this file, we will get our result in the confident AI dashboard. These are the overall result for these matrices: answer relevancy, tool correctness, biasness, toxicity, and medical accuracy. So I am going to show you the answer relevancy metric report. So this is the overall overview of this system for this particular metric, answer relevancy. And inside the test cases, this is the overall report, the input and the output questions. And this test case is fail. And DeepEval is showing the reason behind why this test is failed. And LLM as a judge score it 0.54 because it contained the several irrelevant statement in the answer. So this was the functional evaluation of the multi-LLM system. And apart from this, we also perform the security testing on the system as well with the help of Promptfoo. This is the configuration YAML file. Again, Promptfoo is an open source library to generate the multiple attacks on the system so we can detect the vulnerabilities in the system. So we mainly divide it into four main parts. First is the target. First is the target. So we are targeting the endpoint of the system. Then we are using the GPT model to generate the attacks. Then we are describing the purpose of the system. So Promptfoo can generate the relevant test cases. Then we have plugins. Plugins are the function or vulnerabilities to detect in the system. We have medical hallucination, anchoring biasing, and medical off-label use. So these plugins are relevant to the medical domain. Then last we have strategies. So strategies are the techniques to deliver the plugins in the system. Now I am going to run it with Promptfoo red team run. So by running this, Promptfoo will generate attack on our system and we will get our report with Promptfoo red team report. So this is the overall report for the system. It has two critical vulnerabilities like medical hallucination and medical incorrect knowledge. This means that the system is generating answer outside of its knowledge base. It has two high vulnerabilities: resource hijacking, medical off-label use. This means that the system is easily tricked into another domain. It has two medium vulnerabilities and three low vulnerabilities as well. And it includes the gender biasness, race biasness, and other religions. So this was the complete security testing with Promptfoo. So moving to the next part, which is how to perform the observability and performance testing with LangSmith. So LangSmith is again an open source tool. It helps us to trace and monitor deep inside our system. So to show you the traceability, I asked the system this query: what are the latest treatment of cancer? And it responds from the web search agent. And now if I open the LangSmith platform and look at the last trace, what are the latest treatment of the cancer? So it is showing me the overall latency, tokens, and the cause. So inside this trace, it is showing the completely steps it take to answer this. First, it analyze the input, then it is using the route to agent node, then web search agent. So with the help of LangSmith, we can easily detect the root cause of the failure. We can manage the cost at every step. So this was the complete overview how to perform the functional testing with DeepEval, security testing with Promptfoo, and the observability with LangSmith. Thank you.